Hello, everyone. Welcome to the sustainability lesson brought to you by your friends at Gensler. And we are thrilled to be the final lesson of 2023, and we've got a great one for you. We are intending to cover a few things here, all about sustainability, including how we can really connect some of these themes and topics to your projects. We also want to talk through ways that the profession, both architects and contractors and engineers, are really making to enable a brighter future in their work. And then we're going to kind of get into some nuts and bolts about how some of those steps we can do, both from early design and also in kind of operating your facility, your building. And last session, I think a lot of teams had great questions about professional licensure and accreditation, and there is accreditation for sustainability and a few kind of related fields. So we'll touch on that as well. But all in all, we really hope that you will take some of these topics and really think about your own projects and kind of applying some of these themes to that. So without further ado, Dina will take it away first. Thank you.
Hi, I'm Dina Wingberg, a project architect with Gensler, here to talk with you a little bit about the professional commitments of the ACE field. Members of the ACE field have a great responsibility as stewards of the environment. There is so much power in the choices that we make every day as professionals. From choosing where to locate buildings on a site to consider solar benefits or impacts to the ecosystem, to the building materials and interior finishes that architects recommend to use within their designs. From the management plans required of a general contractor to defer construction waste from entering the landfill, to sourcing materials on the project from within a smaller distance from the site to limit unnecessary carbon emissions. And from engineers designing energy-efficient heating, cooling, and lighting systems to engineering ways to reduce water usage across the site and buildings. Architects and interior designers are on the front lines with their clients from the start of a project through the finish. They must first then understand what the client really needs and what their goals are for sustainability on the project, and work to achieve at a minimum what their needs are. Beyond that baseline, as trusted advisors to their clients, architects can and should encourage achievement of greater sustainable design metrics and establish their own internal standards. The American Institute of Architects, considered the leading professional organization for architects in the US, created their AIA 2030 commitment as an actionable climate strategy that provides a set of standards and goals for reaching net zero emissions in the built environment. So far, more than 1,300 firms have already committed to reaching carbon neutrality by 2030 through an accountability system of tracking their energy performance and benchmarking their projects against industry averages. Construction professionals probably bear some of the greatest weight of the ACE field, as they are primarily responsible for the implementation of the project's sustainable design. Contractors hold the checkbook for purchasing products and materials, and they reign over the job site, how much it pollutes air, soil, and water, how much landfill waste it produces, and how effectively workers do their part to advance high performance. The Associated General Contractors is just one professional organization that stands behind the contractor's commitment to sustainable building practices, the industry's way of assessing and tracking what it means to be a green contractor. Created by contractors for contractors, it's a great way to get started on a sustainability journey, or for those who are well along, to apply a yardstick to their progress. Similar to the responsibilities of the architect, engineers are an important part of the team's sustainability strategies from the earliest design phases. Engineers must be collaborators on solutions that will meet resilience goals, but also work within the project's budget and needs. To that end, various professional engineering societies have established guidelines and commitments to sustainability for their members, understanding that there is an imperative to take informed and intentional actions now to both reduce greenhouse gas emissions and adapt to the impacts of a changing climate. To talk a little more about carbon emissions and what that means, I'll pass it over to Lindsay.
Thanks, Dina. In order to meet our organizational commitments, the first step is to understanding what types of carbon have the largest impact on our work and where do we have the most control. When looking at the entire building life cycle, we track carbon along all stages, from sourcing of the material through the end of life. And specifically, when we look at embodied carbon, this is the amount of carbon and greenhouse gases that are associated with a product throughout its entire life cycle. So when we start to select materials, it's important that we look at the carbon impact of that material. And there are three main ways to do that. The first is to reduce the amount of added material in our work altogether. Where there's no material, there's no carbon. So in general, less is more when it comes to reducing the amount of material. The second is to know the content in your material. What ingredients are going into the material that you're looking to select? And are there alternatives out there that provide the same amount of aesthetic that you're looking for and performance when it comes to where that material is being applied? In general, it's always good to do your research and make sure there's not a better option out there for you. The third is to know where your material is being sourced and how it is being manufactured. Those two things can have a big impact on the amount of carbon you're talking about in looking at a material. So opt for readily renewable or responsibly sourced materials, and make sure you do your research to understand how those materials are being created. What is the manufacturing process like? And what type of energy and how much energy are they using to create that material? With these three things, and knowing your material well, you should be able to reduce the amount of embodied carbon within your work and make educated decisions about your materiality. So with that, I will hand it off to Casey now to discuss the second type of carbon we are aiming to reduce in our work.
Thanks, Lindsay, for walking us through that. So Lindsay talked about embodied carbon, which is the amount of carbon used to build the building. What we're going to talk about now is operational carbon. So that's the amount of carbon that you're using over the lifespan of the building. That comes in essentially as an equation from two parts. One is what we already talked a little bit about, which is the amount of energy you use, that operational energy demand. So that's a combination of your lighting power density and the amount of energy you use. So lighting, heating, cooling, all the different stuff you have plugged in, TVs, refrigerators, all that. Coupled with that is where your fuel comes from. So all energy, the energy grid is made by fuel and powered by fuel. So that's can come in the form here in Raleigh. Most of that comes from Sharon Harris, which is the nuclear plant just south of town. But it can also come in the form of natural gas, oil, coal. Natural gas, oil, and coal, those are the three really high carbon types of energy use in energy plants. The other six that are listed here, and these are not the exclusive list, but nuclear, like I mentioned, wind, we have a lot of wind, some wind turbines off the coast here, but you see those a lot, especially in the Midwest. Solar, there's a lot of solar panels going up around North Carolina. Hydropower, if you've ever been to Lake Hyco, just west of Raleigh here, there's a hydroelectric dam there. Geothermal is another option that you can use. That's water going into the earth to power your building and to help cool your building. And then tidal energy, which is another option. But all those go together to create your the amount of operational carbon that you're using for your building. So that's talking about greenhouse gas emissions, your operational carbon consumption, and those all together make up your operational carbon footprint.
Good afternoon, everyone. My name is Oluwarotimi Oshiberu, and I am a technical designer at Gensler. Today, I'll be talking about sustainability accreditation and the process. So what is accreditation? Why is it important? Sustainability accreditation is a verification and certification process conducted by an independent third party to acknowledge that a development of building has attained a certain level of sustainability. It is important because it serves as a way of verifying that buildings are functioning and operating as intended in terms of sustainability. So there are a lot of sustainability certifications, and here are three very popular ones: LEED, WELL, and FitWell. LEED focuses on environmental impact, while WELL and FitWell focuses on health impact. There's a lot of crossover within this certification, so it's possible to get multiple because some certifications help with getting other certifications. Looking at the number of projects, you can tell LEED is the most significant or should I say most popular certification in the US, and that is the one we will be looking into in this class. So what is LEED? LEED stands for Leadership in Energy and Environmental Design. It has project typologies which go from the small scale of homes to the large scale of neighborhood development. For the classes, for the class, we'll be using base building because you're doing new construction. So your projects will be classified under the base building, new construction. So what are the categories? Location and transportation, sustainable sites, all the way to regional priority. Each category has a number of ways you can get points to help achieve the category. So depending on the number of points you get, you can go from being LEED certified to LEED platinum based on how many points you get in all the categories. So what is the process? You register your projects, you document it, you send in your documentation, it is reviewed, and based on your points, you get certified. And there is a registration fee for LEED, which is $1,200. So here's a brief overview of a project checklist with the breakdown under each categories and how many points you can get for each subcategories. On the LEED website, they also give you more instruction as to how you can achieve each credit. In conclusion, LEED transforms the way buildings are built and operated, and at the end of the day, it improves the quality of life for those in the building and those of us outside the building, the community, and the rest of the world. Thank you.
Hello, I'm Nabila Bustillos at Gensler.
Hey, my name is David Gange. I'm an architect in the Raleigh office of Gensler.
And we're going to be talking about integrating resilient design strategies. So one of the first things you have to do is think big, zoom out, look at the issues, see what would make sense to the site, and then establish what the weak links are in the project and in the environment. And always look at the community first and see what's happening, what are the issues, and how your project might affect other people. And a lot of that goes into using vernacular design, use materials that make sense, use design strategies that fit the community, and then think about different policies that the area might have and different operational costs and timelines that might happen with this, whatever system you're choosing to use. And always look at ecological solutions to the problem and not just construction solutions. And then most importantly, think about timeline. How long is this going to last? What is most important? What is least? And think about it that way.
So this is an example of big picture thinking. So this is a project that is currently under design. It's in Lower Manhattan in New York City. So of course, New York City is surrounded by water, and it's particularly vulnerable to storm surge, to flooding, to hurricanes, such as Hurricane Sandy that occurred a few years ago. So this project is trying to protect Manhattan from flooding. So they're trying to use different technologies and parks and hard walls and terraced landscapes to help mitigate this risk. And so the whole town is involved. From the architect, which is BIG, which is Bjarke Ingels Group, a ton of people from the city and city planners are getting together and having meetings and talking about the risks and what they want this thing to look like. They want it to be a park. They don't want it to look like a giant concrete barrier around the city. They want the city to engage this process and this design. So as we go forward, the public is involved in those conversations, and it will be an exciting design, and will also help lead the future of coastal cities into different ideas. So next we look at kind of the local applications to this. So there's various ways that we can control flooding. This is just one of them. So these are physical barriers that are around town. So the bottom left-hand corner is just basically a fence that holds back water as it laps over the Broadway. And in the upper left-hand corner, this is an example of an active system. So most of the time it's just sitting in the sidewalk. You can ride your bike over it, you can walk over it, you don't even notice it's there. But in the event of flooding or some sort of event, it pops up and becomes a barrier to help protect the buildings in the town. To the right, the bottom right-hand corner is a diagram of a different system, an active system, but it uses the power of that water to actually lift the gate. So as the water moves into the tank, it drops into the tube and raises through pneumatic action the gate and becomes a barrier.
So moving into more big picture thinking, this is a Coastal Studies Institute that's been mentioned this semester so far. It's a 200-acre site with a lot of different programming, and they really had to zoom out and look at the big picture of the site and establish different systems that could work. So they did geothermal, they did bioretention and wetlands to restore habitats, and then also are researching living shoreline stabilization and doing rainwater collection and wastewater treatment, all within this larger site. So zooming in to the lab building, they use very similar systems on a smaller scale with rainwater collection, PV panels, condensation collection, and on-site wastewater treatment, again, the geothermal, and then the wetlands in the surrounding area that are used for natural habitat restoration. So with that, they also thought more about daylighting, and daylighting is something that encourages a lot of the form of a building. A lot of projects, most buildings tend to try to keep as much daylight in the project as possible while still being efficient. So one of the sort of rules of thumb is that daylight only reaches about 30 feet into a project. So you want to think about, if you want daylight through your entire project, it probably shouldn't be more than 60 feet total or just around there, depending on what spaces you're trying to daylight. So moving into a sort of different example, it's more of a study, very similar to the project you're doing. They're trying to see, okay, if we want this building on this coast, what can we do and how do we do it? So starting off, they identified all the hazards in the area, like heat, wind loads, moving water, low elevation, storm surges, etc. And they decided, okay, the first thing we need to do to mitigate these issues is elevate the project and make sure that any equipment that needs to be protected can be protected first. And then with that, they continued to develop more ideas and create layers and layers and layers to the project that considered how people's safety and the safety of the project and making sure that everything ran smoothly. So you can see how something very, very simple, like a building on the shoreline, can become something much bigger.
Thank you.
Thank you very much.